Good day, class. Today's class will be looking at Newton's laws of motion. Isaac Newton propounded 3 laws that explains motion. First, today we'll be looking at the first law. Now, the first law looks at the idea of inertia. What is inertia? If you have a phone on this tool, this phone continues to remain on this tool. Naturally, this phone is supposed to remain here forever. It is at rest, it wants to remain at rest. If I have a football, I throw a football on the ground and the ball begins to roll. Naturally, that ball wants to roll forever. Inertia simply tells us that a body at rest wants to remain at rest. A body that is moving wants to continue to move with uniform velocity forever. If we look at what we have here, the idea of inertia, the tendency of a body to remain at rest or in uniform motion is simply known as what? Inertia. So if you look at the first law of motion, inertia explains the first law of motion. The first law of motion tells us that everybody continues in its state of rest. Everybody continues in its state of rest. If I have this phone here, this phone wants to continue to rest here forever. If you have a ball, a football that is rolling, the ball wants to continue to roll forever. So everybody continues in its state of rest or in uniform motion in a straight line, unless acted on by what? An external force. That is Newton's first law of motion. The body continues in its state of rest or in uniform motion unless acted on by what? An external force. If I keep this phone here, close this office, I go. If I come back tomorrow, this phone is supposed to remain here. That is Newton's law of motion. Now, if I come tomorrow, I see this phone on the ground, it means that there are external forces or an external force that must have acted on this phone. First law, a body remains at rest forever unless acted on by what? An external force. If someone comes here, maybe a thief, comes here and picks this phone, that thief is the external force. If a wind blows or water pours on something, this ball slides and hits this phone. The phone now has left its original position and has taken a new position. Now, all of this that has made this phone to lose its position is called what? External force. External forces. Now, these external forces may include any of these if we have a body that is rolling. For example, I am holding a football. I throw the ball on the ground. The ball is rolling. According to Newton's first law of motion and according to inertia, that ball wants to continue to roll forever. But will it roll forever? No. Why? One, friction. As the ball is rolling on the ground, there is friction between the ground and what? The ball. Remember, what is friction? A force that opposes motion. The ball is going forward, friction wants it to what? Go backward, which will eventually lead to what? The ball, stopping of the ball. Now, friction acts on the ball. One, friction can cause that ball to stop. Two, gravity. Gravity is pressing down on the ball as the ball is rolling, which we can call the weight of the ball. Three, air resistance. As the ball is rolling, there is air resistance basically in the opposite direction. So these are forces that can cause a ball that is rolling or that is moving with uniform velocity to reduce speed, slows down, and eventually comes to what? Stop. So if we look at this, everybody continues in its state of rest or in uniform motion in a straight line unless acted on by what? An external force. We have looked at the examples of external forces. One, friction, gravity, and what? Air resistance. There may be other forces. A person comes and kicks the ball, or a person comes and moves this phone. That's an external force. It may be push, it may be pull. These are external forces. So if we relate all of this, we can see that inertia explains the first law of motion. I will go again. Inertia is what? The reluctance of a body at rest to move. A body at rest does not want to move. A body that is moving does not want to stop moving. That is inertia. We relate that to Newton's first law of motion. A body continues in its state of rest or in uniform motion unless acted on by what? An external force. So in summary, Newton's first law of motion is telling us that any body at rest wants to continue to rest, a body that is moving wants to continue to move. But they can change, these things can change when external forces act on these bodies. Now, if we explain the Newton's first law of motion the way we experience it in our everyday life, you are in a car and the car is moving with a certain speed. Immediately the driver steps on the brake, the car suddenly comes to a stop. You observe that you jerk forward. Why? You jerk forward because your body has been moving with a certain speed, a constant certain speed, a uniform velocity, and your body is used to that velocity. Now, if you suddenly stop, your body naturally wants to continue to move with that speed it has been moving with. That is why you jerk forward. First law explains it. A body remains in its state of rest or in uniform motion. You are in the car is moving with a uniform speed. A body continues to move with uniform speed continuously. But now you suddenly stop. What happens? Your body tries to continue to move with that speed, but it cannot. Then you move backwards. All of this explains what? Newton's first law of motion. The thing about this is that Newton's first law of motion tells us what happens when force is applied, external force is applied, or when force changes. Yes, Newton's first law tells us the result, you jerk forward, yes. But it does not tell us how we can calculate this force. It does not tell us how we can calculate this force, which I believe we are going to look at when we look at the second law of motion. From the second law of motion, we then look at how we can derive the general formula we know, which is force equal to mass times what? Acceleration. Thank you. Please subscribe to our channel, Empire School of Physics, and share. Thank you.